Okay. Hello, everyone. Good afternoon. This is Henk Baarbé speaking from the Netherlands. Thanks to the moderator for his kind introduction just a minute ago. I will try to tell you something about our experiences in Europe with Euro 6 technology. And I will start with some prescription of the technology you will see on Euro 6 buses and trucks. Next slide, please. Always find a wall flow type diesel particulate filter. And that's because we have made a particular number requirement in Europe. We also have a particle mass requirement, but that doesn't guarantee a good type of DPF. You will also see in all cases selective catalytic reduction systems. Those are very efficient systems, especially at higher engine loads where you have good exhaust gas temperature. They can reduce it by up to 90, sometimes even 95%. What you will also see is a diesel oxidation catalyst, or you will have a catalyst-coated particulate filter. This oxidation catalyst that serves to support regeneration of the DPF, because it will also oxidize NOs, nitrogen monoxide, into nitrogen dioxide, and nitrogen dioxide is a very aggressive compound which will support the regeneration and lower the light-off temperature for the regeneration. Such a diesel oxidation catalyst increases the share of NO2, and an SCR system has its best efficiency if we have equal shares of NO and NO2. That's because there are several chemical reactions taking place in a SCR, but the fastest one is the reaction which needs equal shares of NO and NO2. And last but not least, such an oxidation catalyst can oxidize harmful hydrocarbons and carbon monoxide, which will further reduce the health effects of the exhaust gases. What we most of the time see is additional exhaust gas recirculation. This helps to reduce the formation of nitrogen oxide during the combustion process. Finally, we see an ammonia slip catalyst in most cases. If you are using a SCR system, a selective catalytic reduction catalyst, you have the risk that not all of the ammonia that's fed to the catalyst is used, so some of it may pass the catalyst, and we don't want ammonia in the atmosphere because it smells badly, but it also has some negative effects on the environment. What we haven't seen yet on heavy-duty engines for trucks and buses, but which is quite common on light-duty vehicles, is a lean NOx trap. It's a system which can absorb nitrogen oxide, especially at lower temperatures. Lower temperatures mean lower loads. And then it has to be regenerated by fuel enrichment. And that's, makes it have a negative effect on fuel consumption. So that's not something we would prefer. But it's a rather cheap system because it's more or less passive. It doesn't need very accurate dosing of urea. Next slide, please. And I think we can... Okay. And that's... okay. There we will say something more about the technology we find. A diesel particulate filter has the disadvantage that you have a slight increase in the exhaust gas pressure, which is inevitable that it causes some increase in fuel consumption. Then, I think most of the audience will know, a filter collects the soot particles And if you're lucky, it's burned at the same rate as it is collected, but during low engine loads, that will not happen. So it will gradually get filled with soot particles, and you will need some periodic regeneration. And if there is no adequate periodic regeneration, there will be some kind of emergency, and there will be malfunctional indicator lamps on the dashboard which will burn, and then you have to take action, go to the garage or follow a certain procedure to start an active regeneration. DPF is sensitive to fuel and loop oil quality. The fuel, because fuel also contains some materials which will burn, not fully burn, and cause ashes to be in the trap also. And for loop oil, it's the same. And if you have a lot of sulfur in the fuel, but I've understood from one of the first presentations, which I could still follow, that you have dropped your sulfur level to 15 ppm. So that should be a reasonably low and good quality of diesel fuel. A DPF also means that it's, even if you have good fuel and good loop oil, that it will still collect some ashes. And once the more ashes there are in the filter, the less space there is to collect soot particles. So every few years, for a passenger car, it's around 200,000 kilometers. I don't know exactly for trucks and buses, but it will probably be every few years. The filter will have to be disinstalled and it has to be cleaned. And then you can use it again for a few years. Then the limitations of the SCR. As I said, an SCR needs a certain minimum temperature. Mostly we say it should be more than 200 degrees centigrade. If the temperature is below 200 degrees, there's still some operation, but with a lower efficiency. And the minimum temperature for it to do something is somewhere between 160 and 180 kilometers. So, no, not kilometers, but degrees centigrade. If you go below 200 degrees Celsius, it's not only the working temperature of the catalyst, but you also need some minimum temperature to convert urea, which you use as a agent, into ammonia. And if that is not done in a proper way, it's not fully converted, you get deposits of ammonia salts which may block the SCR. So in that case, you also have to go to the garage. And the previous slide also said for best performance you need equal shares of NO2. It should be NO and NO2. Next slide, please. On my screen, that's slide number 4. The diesel oxidation catalyst, I already said, it needs low sulfur fuel. It contains precious metals, and these metals will be inactivated if there are sulfur deposits on them. And you can remove these sulfur deposits, but you need very high temperatures, above 400 degrees centigrade, and the less sulfur in the fuel, the less regeneration of the sulfur has to take place, and so you have less fuel consumption. Exhaust gas recirculation, it's a very effective means of reducing the formation of NOx, and we should know that it only works at lower engine loads, because at higher engine loads you need all the oxygen that you can get into the engine, and there's no room for a lot of EGR. Today we mostly see cooled EGR, so the exhaust gases are fed into a heat exchanger, cooled, and then fed into the engine again. It makes it more effective. I also already explained what an ammonia slip catalyst is. I think you will see it in most applications. Next slide, please. Okay. I was told in advance of this conference that you would be interested in the operating costs of Euro 6 in comparison with Euro 5. I already explained to you that Euro 6 always has a particular threat with some increase of exhaust gas back pressure, and an increase of exhaust gas back pressure theoretically means an increase in fuel consumption. But due to technological improvements, what the experience is at the moment, and it's confirmed also by claims from the manufacturers, that modern Euro 6 engines are at least as good as the previous generation of Euro 5 engines. So in comparison with Euro 5, you should not have to fear for a significant increase in fuel consumption. Euro 5 also had SCR systems using AdBlue, but since the nitrogen oxide emissions will have to be lowered much further, you cannot do that by increasing the efficiency of the catalyst only. You will also have to decrease the engine out emissions by, for example, exhaust gas recirculation. And if there's less oxygen, nitrogen oxygen in the raw exhaust coming out of the engine, you need less AdBlue to convert that to oxygen and nitrogen. Then cost of maintenance is always important. There are more parts and more complicated parts on a Euro 6 engine, so theoretically you might need more maintenance, but what we also see is that we have more advanced onboard diagnostic systems which will help to have the maintenance and repair just when it's needed. And I think it will also support the mechanics who will have to carry out that maintenance, so it can be done in a more efficient way. So my personal feeling is that in the end, the cost of maintenance will be of the same order of magnitude as for a Euro 5 bus or truck. Next slide, please. Yeah, that's a concern. We had many measurements of Euro 4, Euro 5 buses and trucks, and what we found is that on the road, during actual operation, they had much higher emissions, especially of nitrogen oxide, than during the approval test. I think in the previous presentation by Mr. Lloyd, he has already explained that the test cycle has changed from the European transient cycle into the world harmonized transient cycle, which is far more representative of normal use of vehicles on the road. So that's one thing that helps. Apart from that, we have what we call in-service conformity requirements, which means that an engine that has been installed in a vehicle still has to meet the requirements, and the manufacturer shall show to the type approval authority periodically that he is testing these vehicles on the road. But first, there are a number of ways you can identify poor real-world performance. In the past, we did that when we did not yet have equipment to test on the road. We did it on the engine test bed, in the laboratory, or on a chassis dynamometer, and then not use the official test cycle, but appropriate test cycle, more representative of normal operation of the vehicles on the road. Normal, which means normal for a bus or for a long-haul truck or a delivery truck. That's complicated because you will have to take the engine out of the vehicle, and especially with modern vehicles, an engine is connected to all kinds of sensors and of the vehicle, which measure the load of the vehicle, and if you take the engine out of the vehicle, it's lacking the information of all these sensors. So you will have to give it fake signals, and then the question is what you measure then still what you should measure? So it's far better to do the measurements on the road, and in the Euro 6 legislation have been developed a method to do that, and that's using a portable emission measurement system, a PEMS we call it, and that they have defined special test trips with certain shares of urban driving, extra urban driving, and motorway driving, and percentages of idling, and a whole range of boundary conditions for these trips. The weighing of the urban part and the extra-urban part is different for heavy trucks and for light trucks, and there is at the moment there is no specific trip requirement for buses, but we're working on that. And maybe a better way to evaluate real-world performance is to take a vehicle, for example, a city bus, equip it with PEMS system, and let it drive on the route it normally drives. A limitation is that the equipment is rather heavy. It needs a generator for power supply, and you don't want to do that with passengers on board. So you artificially load the vehicle, and then you drive behind a normal bus in normal operation. So you can simulate what a bus should be, how it should be performing on the road. More recently, TNO, at our request, has developed another system, and that's called SENSE, and it's using sensor signals. I will come to that in a moment. Next slide, please. First, the PEMS system. That is number 7. Yeah, okay. PEMS systems. PEMS system, I'll show you a picture of one in a moment. It measures the exhaust gas flow, it samples, and it analyzes with a laboratory type analyzer, but a bit smaller than a full-size laboratory. It analyzes the concentrations of carbon monoxide, hydrocarbons, NOx, and particulate matter. And if you multiply the flow and the concentration, you get the emission in grams per second. And if you calculate the distance you travel, you can also make it in grams per kilometer. And if you know the engine power, you can calculate it into grams per kilowatt hour. Just depends on what you would like to know. The advantage of PEMS is that it's very accurate. It's almost as accurate as a full constant volume sampling system in a laboratory, and that you measure in real life. So you have reliable results. There's one big drawback. The equipment is very expensive, and it's very time-consuming to install it on a vehicle. I already said you need a generator because the power supply of the vehicle is usually not good enough. It doesn't have the capacity to support the equipment, which needs quite some electricity because you have a heated sampling line. That's what you need when you want to analyze hydrocarbons. These hydrocarbons, if they cool down, they have a tendency to condensate on the inner walls of the sampling lines, and that's, of course, something you cannot accept. Next slide, please. Here you see two pictures. One is on the left-hand side is the analyzing equipment, and on the right-hand side, I think it's a truck for a semi-trailer, a tractor for a semi-trailer. You see the exhaust gas flow measurement equipment. Next slide, please. Yeah, this picture compares the real-life emissions measured with the PEM system. What TNO often does is they take the second-by-second emissions and also register the speed, what they're driving, and then they collect all the data in the speed interval, speed bin. They collect from 0 to 50, from 50 to 75, and above 75, which is motorway operation. And what you can see, the blue one is not a real measure, because in those days with Euro 3 we didn't have PEMS equipment, so we started measuring with PEMS this Euro 5. Euro 4 didn't really exist in the Netherlands. And what you see here is that regardless of the speed, the Euro 6, which is the brown bar, it has far better performance than Euro 4, Euro 3 and Euro 5 first and second generation. So that says something about the behavior on the road of long-haul trucks. Next slide, please. Then we come to a SEM system. We found out that you could also measure the concentration of NOx using a sensor. And modern trucks, even Euro 5, second generation, and Euro 6 are often, I think in all cases, equipped with a NOx sensor by the manufacturer. A NOx sensor also measures the oxygen. The signal is not always used, but it measures the oxygen. And so from oxygen with a diesel engine, you can rather simply calculate the amount or the concentration of carbon dioxide. You do not need an extra sensor for that. And once you take the ratio between NOx and CO2, it's quite a good metric for the evaluation of real-life performance. Another way to do it is estimate the specific fuel consumption and then calculate from the NOx over CO2 ratio the emissions in gram per kilowatt hour. This SEMS method is less accurate than PEMS, of course. That's unavoidable with sensors. But it's inexpensive equipment and it has easy installation. It takes you maybe 1 or 2 hours to install it on a vehicle and even shorter to dismantle it when you're ready. It doesn't have an effect on the operation of the vehicle, so you can install a data logger and some cables on the vehicle and let it drive for a day or a week in its normal operation and take out the data that has been stored by the data logger, and you can calculate the emissions over normal operation of the vehicle. And because it's cheap and easy, you can do it for a number of days, and the lower accuracy is compensated to a large extent and maybe even overcompensated by the enormous amount of data you get. Of course, it's a challenge to handle such an amount of data. Next slide, please. In 2015, we have tested a number of vehicle makes and types with SEMS, and it says estimated NOx emissions because they are calculated with an assumption about the brake-specific fuel consumption. And these vehicles were tested in normal operation, not in accordance with the in-service conformity procedure, which has fixed shares of rural and city and motorway. So it's in normal operation. What you see is, again, city, rural, and motorway, and these are, I think, it doesn't say this picture, if it's Euro 5 or Euro 6 buses. I think it is Euro 6. But I will send you the report from which this picture was taken, and you can see by yourself what kind of buses it were. We anonymize mostly the makes and names of the buses because we do not want to use these measurements to blame manufacturers for good results. Sometimes, if, for example, the AW vehicle, it's a garbage truck, a garbage collection truck, which has a lot of idling and a lot of very low speeds. So it's understandable that an SCR system works less good for such a vehicle. Next slide, please. We also performed some Euro 6 city bus emissions. We have in a city in the center of the Netherlands, they wanted to invest in new buses, and there were complaints from the public that the buses were still having high emissions, or maybe concerns is a better word. So together with this big city, we tested two buses types. Both were from a German manufacturer. I think if you have good eyesight, you can still recognize which makes they are. I'm not allowed to confirm that, of course. These buses were measured as well in Euro 6 in service conformity conditions. So we could see if they would meet the legislation, and they were tested in city bus operation conditions using the actual routes on which they were to be deployed. Next generation. Next slide, please. Yes. No. The conclusion is both these vehicles, they fulfilled the requirements laid down in the Euro 6 emission regulation, so they did not exceed the in-service conformity limits. What we also saw that there were two routes. One slow route, that's I think the next slide will show that, which had a very low average speed, and one slightly faster route on the outskirts of the city. And what we saw is that city buses are capable of achieving very low real-world NOx emissions during typical bus operation. And they improved at least 20 to 80% compared to Euro 5 city bus we tested in 2010, which was a very clean one. But what we also saw is that one vehicle had substantially higher NOx emissions than the other, and very low load urban driving conditions. I think I can show you that in the next slide, please. No, this is, I think we've already had this. Next slide, please. Yes, this is with the slide number 15. It has the emissions in the in-service conformity trips. And we measured these buses with a low payload, so almost without artificial passengers, and a medium payload and a full payload. And what we saw is that quite peculiar. With a low payload, the emissions were lower than with a medium payload, and with the full payload, they were again lower. Why it says not applicable with the middle one, I'm not sure at the moment. Then these vehicles were tested also in their actual use. This line 8, it says, sorry for it's Dutch, with its line 18 and line 77. They could not be judged to whether they complied with the in-service conformity factors because the trip did not meet the requirements of the in-service conformity requirements. The average speed and things like that. So in-service conformity says the data you collect, the worst 10% you throw away, and then you throw the data away that are achieved at a engine load of less than 20%. We are discussing now in Brussels to change these parameters. And if you cannot collect, cannot produce enough data that may be used, the trip is not valid. And that's where it says WNOT. So, but in all cases where we had a valid trip, these vehicles, these two buses, have met the service requirement, the service conformity requirements of 1.5 conformity factor. Next slide, please. Here have the distance-specific emissions in gram per kilometer, which to show how it differs from vehicle to vehicle and from trip to trip. What we see is the first three are these in-service conformity results again, and then and now not expressed as a conformity factor, but as NOx emissions in gram per kilometer. You can see that on line 8, one bus performed very well. It was 0.3 or so grams per kilometer, which is even for a modern passenger car quite a good value. And the other one, which at first sight it had the same technology, and it performed much less good. In line 77, which was a line with the higher speeds, the difference between these two vehicles was less eminent. Next slide, please. That's overall conclusions of my presentation. And that's Euro 6 means very low emissions of NOx and particulate matter. Real-life NOx performance, however, depends on driving conditions, and it varies strongly from vehicle to vehicle. So just the fact that a vehicle meets the Euro 6 requirements doesn't guarantee that it will also have low real-life emissions. And some vehicles, all of them will probably meet the legal requirements, but some will perform much better than others. And the official in-service conformity test using PEMS does not guarantee low emissions of NOx in all driving conditions. And therefore, I make a final statement, as it were. Ideally, in addition to the Euro 6 criterion, you should perform a PEMS test or a SEMS test when you're comparing vehicles like buses in order to select the best one for your operating conditions. And I think that's the last slide, because the next one is thank you for your attention, and I will be happy to answer questions. Thank you.